The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. So today, eventually, we're going to look at the last section, which is 6.8. And your assignment tonight will be 6.8 along with the chapter review material. Tomorrow, we'll spend class time reviewing for the first test. And on Friday, you'll take the chapter 6 test. There will not be a regular class Zoom meeting on Friday. If you join the Zoom meeting, you'll just see a screen that says, no Zoom today, take your test. All right. Anyway, before we do all of that, a student had some questions from section 6.7. So we're going to start taking a look at those. So this is from section 6.7, number 21. It says, solve the equation, enter your answers as a comma separated list. And here's the equation. H times the quantity 7h minus 8 times the quantity h plus 1 equals 0. First of all, I want to point out that this equation is already set equal to 0. That's a good thing. Secondly, the side that's not 0 is already factored completely. So all we need to do is take each factor on the left side of the equation that contains a variable and set it equal to 0. And then go back and solve each first degree or linear equation. Well, if h equals 0, then h equals 0. If 7h minus 8 equals 0, we'll add 8 to both sides of the equation. 7h equals 8. Divide both sides of the equation by 7, and we get h equals 8/7. H plus 1 equals 0. We'll subtract 1 from both sides. H equals -1. So we've got 0, comma, 8/7, comma, -1. Now, keep in mind, as we talked about, I think it was a couple days ago, when you put 8/7 in, if you put a comma there, it's going to mark it wrong. So you've got to use the right arrow to move the comma outside of the denominator of the fraction. So be sure to do that. Any questions on 21 before we go on? All right, we're going to take a look at number 22 from that same section. This says solve the equation. Again, enter your answers as a comma separated list. We have 2m squared minus 16m equals 2m minus 40. So the first thing I need to do here is put everything on one side of the equation set equal to 0 on the other side. It would be advantageous to have my leading coefficient positive. So since this is the term with a leading coefficient, I'm going to leave that on the left side of the equation, and I'm going to move everything from the right side of the equation over to the left. So I'm going to subtract 2m from both sides and add 40 to both sides of the equation. Now, on the left side of the equation, I have the following: 2m squared minus 16m minus 2 more m is minus 18m plus 40 equals 0. All right. So I've got a trinomial set equal to 0. The trinomial's in standard form. There is a greatest common factor of a 2, which I will factor out. Which gives us that. Now I have a trinomial in the parentheses left over. It's not a perfect square, but it does have a leading coefficient of a 1. So it's going to be 2 times m and then m. My product is going to be 20 and my sum is -9. So -5 and -4 would be the two numbers. Okay. Take each factor that contains a variable and set it equal to 0. So m minus 5 equals 0. M minus 4 equals 0. Remember from yesterday, the 2 does not equal 0. 2 equals 2. I could divide both sides by 2 and get rid of it, or I can just ignore it in this step because I'm trying to solve for the variable. M minus 5 equals 0. We're going to add 5 to both sides of the equation. M equals 5. M minus 4 equals 0. We'll add 4 to both sides of the equation. M equals 4. So M equals 5 and M equals 4. Next up is number 26 from that same section. Let's see here. 26, yes. So 6.7, number 26 says, solve the equation. Enter your answers as a comma separated list. We have 5x cubed equals 5x times x plus 42. I need to get everything on one side of the equation set equal to 0. First thing I'm going to do is on the right side of the equation, I'm going to distribute the 5x. So I get 5x squared plus, let's see, 5 times 42 would be 210, and then x. All right. Now, the highest degree term is 5x cubed. I want that to have a positive coefficient. It's on the left side of the equation. It already has a positive coefficient. If it ain't broke, don't fix it. So we're going to subtract 5x squared and 210x from both sides of the equation. On the left side, I get 5x cubed minus 5x squared minus 210x equals 0. So I now have a trinomial in standard form set equal to 0. Let's see, the greatest common factor would be 5x, and then I have x squared minus, let's see, x, and then minus, let's see, 42 equals 0, like that. Okay, so then I have 5x times, well, the trinomial has a leading coefficient of a 1, but it's not a perfect square. Product is negative 42, sum is negative 1, negative 7 and 6. And that's all equal to 0. So now I have it factored completely, set equal to 0. So 5x equals 0, x minus 7 equals 0, x plus 6 equals 0. 5x equals 0, divide both sides by 5, and we get x equals 0. X minus 7 equals 0, add 7 to both sides, and we get x equals 7. X plus 6 equals 0, subtract 6 from both sides, and we get x equals negative 6. So our answers are 0, 7, and negative 6. It didn't do it in this case, but be careful in the directions. Sometimes when there's a couple of answers, it'll ask you to put the smallest answer first, and I'll have students put the 2 correct answers in, but they'll switch the order, and so it'll mark it wrong. So again, read the directions very carefully each time. All right, number 28 coming up. This is 6.7, number 28. It says, factor the expression, this is part A, factor the expression 4a squared minus 12a. So it's a binomial. It's in standard form. If we take out the greatest common factor of 4a, we have a minus 3 left over. That's all we can do. It's not an equation. We can't solve it. All we can do is factor it. So again, this said factor. Part B says solve the equation. And it says this, 4a squared minus 12a equals 0. So notice the equal sign. This is an equation. We can solve it. It's already in standard form, set equal to 0. So factoring the left-hand side, we get 4a times the quantity a minus 3 equals 0. Taking each factor and setting it equal to 0, 4a equals 0, a minus 3 equals 0. 4a equals 0, divide both sides by 4, and we get a equals 0. A minus 3 equals 0, add 3 to both sides, and we get a equals 3. So again, part A, we can't solve it. We can only factor it. Part B, we have to factor it and go on and solve it. All right, that was the questions that were by request. Do any of you have any questions before we proceed? If so, now is the time to speak. Okay, I'll take that as a no. 6.8. So applications of quadratic equations. So we're going to do some applications or word problems or story problems, whatever you want to call it. First of all, I want to do a little bit of geometry review. The area of a rectangle. So area equals length times width, or length times width. Okay. Now, we have the following problem. It says billiards, and then it goes on to say pool tables, which I don't know why, because pool and billiards are not the same thing. If you live in Britain, you know that. But anyway, pool tables are rectangular. Okay, so we're dealing with a rectangle. And their length is twice the width. Let's see, we'll call this the length, and this the width. If their length is twice the width, the length is being compared to the width. If we call the width x, the length would be twice that, or 2x. Okay? It says the length is twice the width. Find the dimensions, so that would be the length and width, of a pool table if it occupies 50 square feet of floor space. So the area is 50 square feet. All right. So using this formula, 50 equals 2x times x. That is the length times the width. Okay. So there's our equation describing the situation. I'm going to go on and simplify the right-hand side. 2x times x would be 2x squared. Okay. This is a second-degree equation, so I'm going to put it in standard form. That is, everything on one side set equal to 0 on the other side. It doesn't really matter which side is 0. My leading term, in this case, my highest powered term is 2x squared. Where it is, it already has a positive coefficient, so I'm going to move everything over to the right side of the equation. So I'm going to get 0 equals 2x squared minus 50. Okay? Now, on the right side, I can factor out a 2. X squared minus 25 would be the difference of 2 squares, because it would be x squared minus 5 squared. So now I've factored the right side completely. 0 equals 2 times the quantity x plus 5 times the quantity x minus 5. So now, to solve this equation, we're going to take each factor that contains a variable and set it equal to 0. Again, we don't take 2 equals 0, but we could divide both sides by 2 and just get rid of it, so we'll just ignore it. X plus 5 equals 0. Subtract 5 from both sides. X equals negative 5. X minus 5 equals 0. Add 5 to both sides, x equals 5. So we have two solutions to the equation. X is negative 5 and x is 5. But let's go back to the actual situation. We're dealing with the dimensions of a rectangle. We're dealing with a length and a width. Well, a length or a width can't be a negative number, right? A distance can't be negative. So even though x equals negative 5, is a solution to the equation that we created, it's not a valid solution to the actual problem. So cross that out. X equals 5 would work. So now I've got to go back over here. Well, the width is 5 and the length is 2 times 5, or 10. But there's still something missing, and that is the units. If the area is square feet, the length would be feet and the width would be feet. So our answer, length, 10 feet, width, 5 feet. Notice that the length is twice the width, 10 is twice 5. The area, 10 times 5 is 50, feet times feet, square feet. Any questions about this particular example before we go on? Okay. Let's take a look at another example. Before we do that, let's review the formula for the area of a triangle. Okay. Now, the triangle, you have the base and the height. Okay. The area of a triangle is 1/2 the base times the height, or sometimes people write it like this, which is basically the same thing. Any questions about the formula for the area of a triangle? Area equals 1/2 the base times the height. Okay. We have the following situation. It says sailboats. Refer to the diagram of a sail shown here. So let me make an attempt at drawing the sail. Okay, so we have this sail on a sailboat. This is called the foot, and this is called the loof. Okay, all right. It says, refer to the diagram of the sail shown here. The length of the loof is 3 times longer than the length of the foot of the sail. Find the length of the foot and the length of the loof. They also tell us in a picture that the area is 24 square feet. Okay, now let's go back again. The length of the loof is 3 times longer than the length of the foot. So the loof is being compared to the foot. So we'll call the foot X. The length of the loof 3 times would be 3x. Okay. So now, how does that all work in terms of base and height? Well, this is the base down here, and this is the height over there. All right. Sorry, I'm turning my board around, and that's why it keeps dinging. So if the area is 1/2 the base times the height, the area 24 would be 1/2 the base, which is x, times the height, which is 3x. So we get the following situation. Any questions before we proceed? Okay, so now 1/2 times x times 3x would be 3/2 x squared. Again, any question how I got that? All right. Well, I want to put this thing in standard form. So I'm going to subtract 24 from both sides of the equation, which gives me this. Now, I've got a fraction coefficient. I could live with it, but I would rather not. So I'm going to get rid of it. And to get rid of it, I'm going to clear the fraction. This goes back to beginning algebra days. If we multiply both sides of the equation by the least common denominator, we'll clear the fraction. Well, the only denominators there are implied ones and the 2. So the least common denominator is 2. So I'm going to multiply both sides of the equation by 2. 2 times 0 is 0. 2 times 3/2 x squared is 3x squared. And 2 times minus 24 is minus 48. Okay, so all I did there was clear the fractions. Any questions there? All right, so now I'm going to take out the greatest common factor, which is a 3. I'm going to factor what remains as the difference of 2 squares. So I'm going to take each factor on the right side of the equation that contains a variable, and set it equal to 0 and solve it. So I'm going to ignore the 3, or I could divide both sides by 3 and just get rid of it. So x plus 4 equals 0, x minus 4 equals 0. If x plus 4 equals 0, subtracting 4 from both sides, we get x equals -4. X minus 4 equals 0, add 4 to both sides, we get x equals 4. Well, once again, we're dealing with the foot and the loof, however you say that. Those are distances or lengths or widths, whatever. So they can't be negative. Even though -4 is a solution to the equation, it doesn't fit the actual problem. So if x is 4, this would be 4, and 3 times 4 would be 12. What are the units? Feet or square feet. So let's see. The foot is 4 feet and the loof is 12 feet. So foot equals 4 feet, loof equals 12 feet, and there are your 2 answers to that problem. Any questions about that one? Okay. Next, we're going to look at a problem that involves specifically not just a triangle, but a right triangle, meaning that 2 of the sides meet at a right angle, a 90-degree angle, or that you could say that they're perpendicular, okay? Typically, when you have a right angle, you put the little box there to show that it's a right angle. Now, in this case, we're not dealing with the area, but we're dealing with the lengths of the sides of this right triangle. There is a formula called the Pythagorean theorem that a man named Pythagoras came up with many, many moons ago. And he used the following labels, all right? The longest side, which is called the hypotenuse. I'm not sure if that's how you spell it, but well, let's see if it is. Yes, the shorter sides are called the legs, okay? The hypotenuse is labeled as C, and the 2 legs are labeled as A and B. Now, the following is true for a right triangle. A squared plus B squared equals C squared. This is called the Pythagorean theorem. C must be the longest side of the triangle, the hypotenuse. The legs, A and B, it doesn't matter which one you label as A and which one you label as B, because addition is commutative. So in fact, we could switch the order of these and it wouldn't change the equation, okay? So the hypotenuse is C, the 2 legs are A and B. Now, any questions about that formula? Again, we're using it when we're dealing with the lengths of the sides as opposed to the area. We have the following situation. It says a builder of a high ropes adventure course wants to secure a pole by attaching a support cable from the anchor stake 8 yards from its base, all right? And what we have in this situation is, this is the stake right here, okay? And let's see, what else do they do? This is the base. They want to put a stake right here, and they're going to suspend a cable right there, okay? So it says a builder of a high ropes adventure course wants to secure a pole by attaching a support cable from an anchor stake 8 yards from its base. So this distance right here is 8 yards to a point 6 yards up the pole. So this distance here is 6 yards. Okay. How long should the cable be? So our unknown is C, okay? All right, tell you what, let's call it, well, let's call it X. So C equals X. So what we've got is this. We've got this triangle, and the lengths of the sides are 6 yards, 8 yards, and X yards. Okay, if we go away from the picture and just the actual triangle. All right, so this is A, B, and C. So using the formula, I get the following situation. 6 squared plus 8 squared equals X squared. Okay? Any questions there? 36 plus 64 equals X squared. 100 equals X squared. I have a second degree equation. I'm going to put it in standard form. I'm going to put everything on the right-hand side. So I get 0 equals X squared minus 100. Now I'm going to factor the right-hand side, and that would be the difference of two squares, X plus 10, X minus 10. Taking each factor that contains a variable and setting it equal to 0, we get the following two first-degree equations. Solving the first equation, subtracting 10 from both sides, we get X equals negative 10. Solving the second equation, we add 10 to both sides, we get X equals positive 10. And once again, we're dealing with distances or lengths. So X couldn't be negative. It would be 10 yards. So how long should the cable be? 10 yards. Now, you might be saying, why do we keep doing all this and finding a positive and a negative solution, and then we keep throwing out the negative solutions? Well, all of these problems in this section deal with lengths, distances, widths, those kinds of things. And length or distance can't be negative. Time can't be negative, even though science fiction would tell you it could be, okay? So in those cases, we may get a positive and a negative solution, but the negative solution doesn't work in the problem. Now, there are other application problems where both answers will be valid. I've even seen problems where you get a positive and a negative, and depending on the situation, the negative works and the positive one doesn't. So it depends on what the application is. If you're dealing with distance or length or width or time, you can't use the negative answers. All right, any questions about this problem? Okay, let's take a look at another problem. And this one says, a tree was blown over in a windstorm. Find X, then find the height of the tree when it was standing upright. I'm sure you've all heard the joke where there's the math problem and the instructions say find X, and somebody goes, it's right here. Okay, we're not doing that. We're going to actually find a value for it. Okay, let me draw a picture here. Let's see. We've got this tree. And here's the ground. And here's part of the trunk. And then it broke off like this. And then we've got this. You can see that I am not an artist, maybe a con artist, but that's about it. So there's this evergreen tree. All right, so what we have here, so there's this tree and it's busted off and snapped off, but it's formed a right angle, or excuse me, a right triangle. So basically, here's our right triangle, right there and right there, okay? I'll give that tree a little bit more. Okay, now we are given the following information. We're told that this is X feet, that this is X plus 4 feet, and that this is X plus 2 feet. So this triangle that's formed with the ground, the piece of the trunk that's still standing, and the busted piece of trunk and the tree looks like this, okay? Now, which is the longest side? The X plus 4. So that is C. These other two sides, A and B. And again, it doesn't matter which one's A or which one's B. It doesn't affect the formula. Using the fact that A squared plus B squared equals C squared, we get the following. X plus 2, the quantity squared, plus X, the quantity squared, equals X plus 4, the quantity squared. Any questions so far? All right. So recall how you expand this situation. X plus 2, the quantity squared would be like X plus 2 times X plus 2, and then plus X squared equals X plus 4 times X plus 4. Okay. Foiling things together, we get X squared plus 2X plus 2X plus 4 plus X squared equals X squared plus 4X plus 4X plus 16. Okay. Combining like terms on the left side of the equation, I've got 2X squared plus 4X plus 4 equals X squared plus 8X plus 16. This is a second degree equation, so I want to put it in standard form. My leading term, my highest coefficient of X squared is 2X squared. So basically, I want to put everything over on the left side of the equation so that my leading term will be positive, just because it's easier to factor that way. So what have I got? I've got X squared minus 4X minus 12 equals 0. So after all of that, I now have an equation in standard form that will help me determine what X is. Any questions? All right, so we have a trinomial. It's in descending powers. There's no greatest common factor. It's not a perfect square. It has a leading coefficient of a 1. Let's see, the product is negative 12 and the sum is negative 4. How about negative 6 and 2? Negative 6 and 2. Take each factor that contains a variable and set it equal to 0 and solve it. So I'm going to add 6 to the first equation on both sides. X is 6. Subtract 2 from both sides on the second one. X is negative 2. Once again, X has to be a positive value because of the scenario. So let's see. X feet, this would be 6 feet. This would be 6 plus, 2, which is 8 feet. This would be 6 plus 4, which is 10 feet. Now, let me read the directions again. It says a tree was blown over in a windstorm. Find X, okay? So X is 6 feet. Then find the height of the tree when it was standing upright. So what have we got? We've got this piece plus that piece, which would be 6 plus 10, so 16 feet. All right, so this tree originally was 16 feet high. It broke off at the 6-foot level. The piece that broke off was 10 feet. Anyway, any questions about this problem? Okay, let's go back and do another one that was a rectangle. Let's see here. Okay, this says insulation. The area of a rectangular slab of foam insulation is 36 square meters. Find the dimensions of the slab. All right, so we've got this picture of a rectangular slab, and we are told that, let's see, this dimension is W meters, and this other dimension is 2W plus 1 meters. And we're told that the total area is 36 square meters. Okay, so the lengths of the two sides are W and 2W plus 1. And the total area is 36 square meters. So we're dealing with a rectangle. Area equals length times width. So 36 equals 2W plus 1 times W. Now, there is debate amongst mathematicians as to which side is the length and which side is the width. Some would say the length is the longest side and the width is the shorter side, in which case 2W plus 1 would be the length and W would be the width. Others say that the horizontal side is the length and the vertical side is the width, in which case the length would be W and the width would be 2W plus 1. But in either case, you're multiplying them, and multiplication is commutative. So to solve this, it doesn't matter. It would not be a fair question for me to say, looking at this example, what's the length or what's the width? Because there's still debate about that, okay? I'm not going to do that. Anyway, so we've got the following. 36 equals 2W squared plus W. 2W squared. I'm going to subtract 36 from both sides. So I get 0 equals 2W squared plus W minus 36. Okay. So I now have a second degree equation in standard form, set equal to 0. And let's see here. I'm going to have to use grouping or trial and check. I'm going to use grouping. So if A is 2 and B is 1 and C is negative 36, the product is negative 72 and the sum is 1. How about 9 and negative 8? 9 times negative 8 is negative 72. 9 plus negative 8 is positive 1. So now my equation becomes 0 equals 2W squared plus 9W minus 8W minus 36. Okay. Factoring by grouping, 0 equals, let's see, what do we get here? 2, oh, it's not going to be a 2. It's going to be W and then 2W plus 9. And this is going to be 2W plus 9. And this is going to be a minus 4. So 0 equals 2W plus 9 times W minus 4. Any questions about that? All right. Take each factor that contains a variable, set it equal to 0 and solve it. 2W plus 9 equals 0. Subtract 9 from both sides of the equation. 2W equals negative 9. Divide both sides by 2. W equals negative 9 halves. W minus 4 equals 0. Add 4 to both sides of the equation. W equals 4. Once again, we're dealing with distance. So if W is negative 9 halves, we're going to have negative dimensions here and here. So it can't be that. If W is 4, then this would be what? 4 meters. And 2 times 4 is 8 plus 1 is 9 meters. So let's see, what did it say? Find the dimensions. It would be 4 meters by 9 meters. Okay. Any questions about that one? All righty. Let's take a look at another example. And this one says, let's see here. To create, oh, here we go. To create some space to work under the front end of a car, a mechanic drives it up steel ramps. The ramp is 1 foot longer than the back, and the base is 2 feet longer than the back of the ramp. Find the length of each side of the ramp. Okay, you can't see the picture, so let me attempt to draw the picture. Okay, so we've got the ground here. And we've got, let's see here. There's this piece. And this piece. So there's our ramp. And we have this lovely blue car. Let's see here. Okay, now we're also told that this is a right angle. This is the base. This is the back. Okay, so to create some space to work under the front end of a car, a mechanic drives it up steel ramps. A ramp is 1 foot longer than the back. So the ramp would be this piece here, right? And it's 1 foot longer than the back. And then it says the base is 2 feet longer than the back. So I guess we should call this the ramp. Okay. Notice the ramp is being compared to the back and the base is being compared to the back. So the back is the center of the universe for this problem. So we're going to call the back X. The ramp is 1 foot longer than the back, so that would be X plus 1. The base is 2 feet longer than the back, that would be X plus 2. So basically we have a triangle, a right triangle, and the sides are X, X plus 1, and X plus 2. All right, now, which side is longest? X, X plus 1, or X plus 2? X plus 2, so that's the hypotenuse. This is C, and these others are going to be A and B. All right, so again, A squared plus B squared equals C squared. So X squared plus X plus, X plus 1, my bad. X plus 1 squared equals X plus 2 squared. Any questions how I got that? All right, so this is X squared plus X plus 1 times X plus 1 equals X plus 2 times X plus 2. Foiling the two binomial perfect squares, we've got X squared plus X squared plus X plus 1 equals X squared plus 2X plus 2X plus 4. Combining like terms, we've got 2X squared plus 2X plus 1 equals X squared plus 4X plus 4. I'm going to shove everything over to the left side of the equation, so my leading term will have a positive coefficient. I'm going to subtract X squared from both sides, subtract 4X from both sides, and subtract 4 from both sides. On the left, I get X squared minus 2X minus 3 equals, on the right side, 0. Factoring this, let's see, the product is -3 and the sum is -2. So -3 and 1. Take each factor that contains a variable and set it equal to 0. Solve each first degree equation. Add 3 to both sides. X is 3. Subtract 1 from both sides. X is -1. And once again, we throw out the negative value. So X is 3. So this would be what? 3, 4, and 5. And let's see. Oh, it said a ramp is 1 foot longer than the back and the base is 2 feet longer. So these are all units of feet. Find the length of each side of the ramp. So the base is 5 feet, the back is 3 feet, and the ramp is 4 feet. And there you have it. Okay. The most common mistake students make with this formula is right here. Instead of expanding it and multiplying it, they think that this is x squared plus 1 squared. That's not true. So be careful with that. So again, for this evening, 6.8, as well as the chapter review questions. Tomorrow during class, we will go over anything that you want to look at in terms of chapter 6 to review for the test. On Friday, there will be no official class meeting. If you come and join a Zoom meeting at 11:30, you'll just see a screen that'll say, no Zoom meeting today, just take your test. I will have an office hour this afternoon at 1:15, from 1:15 to 2:15, if you have any questions then. Otherwise, have a great day. And I'm going to go ahead and stop the recording.